In this video, we're going to be talking about the y-intercept from slope-intercept form. So we will be looking at equations, graphs, and tables. So in this first one right here, the y-intercept of a linear equation is the b when we have our linear function in slope-intercept form. So on example A, we have y equals 3/4 x minus 2. So the tail end of this equation, the constant, is your y-intercept. So your y-intercept is -2. And that's why it's listed here as b equals -2. On example B, as you can see, there's not a constant at the end of this equation or anywhere in the equation. It says y equals 7x. So it's basically like saying y equals 7x plus 0. And since it's 0, 0 doesn't have a value, so it's not listed. So your y-intercept is 0 because this particular linear function goes through the origin. So when we look at graphs, the y-intercept basically with a graph is where the linear function or the line goes through the y-axis. Your y-axis runs up and down or vertical on your coordinate plane. So this line right here is intersecting the y-axis at +3. The line intersects the y-axis at the ordered pair 0, 3. So the y-intercept is +3. Now with tables, sometimes you get a table where it's very simple to identify the y-intercept because just like with a graph where the line went through the y-axis was 0, 3, the 0 was the x-coordinate. The y-coordinate was 3. So on this one right here, when you're looking at your table, if you can see that you have an ordered pair that has an x-coordinate of 0, then that means that the y-coordinate is your y-intercept. So in this case, 0, 6 tells us that our y-intercept is 6. And then sometimes you get a table where it's not as obvious. As you can see with this table, there isn't an ordered pair that has an x-coordinate of x. So what you have to do is a little bit more work involved. You're going to have to figure out what the pattern or the rule is. So as you can see here in the x row, we're counting by 2s. So we have 2, 4, 6, 8. And then down here in the y row, your y coordinates are 10, 20, 30, 40. Therefore, they're counting by 10s. So what you have to do is we have to count backwards to find what the ordered pair would be when I have an x-coordinate of 0. So if I'm adding 2s to go along this table, to find the number before it, I would do the opposite operation of subtract 2. So if I take 2 and I subtract 2, that would give me 0. So the same thing down here. To find the corresponding y to the x-coordinate of 0, since I was counting by 10s here, I'm going to subtract 10 to find the corresponding ordered pair. So that would be 0 as well. 2 minus 2 is 0. 10 minus 10 is 0. That means that this particular linear function would go through the origin because it goes 0, 0. And that means that my y-intercept is 0 because my y-coordinate is 0.